so let's get going. So if we talk about one of the things that happened in the last lesson, we spoke about how in grade 10, and we still use this now, but SOHCAHTOA got a lot of airtime, got a lot of attention because it told us about the trig ratios sine, cos, and tan. Now in grade 11, there's a bit of a shift to seeing trigonometry as X, Y, and R, or in terms of X, Y, and R. And the reason we use this is we have to sort of deal with angles that are greater than 90. So if we have sine of 210, if we have only SOHCAHTOA as the basic tool for helping us understand what the sine of 210 means, it means we need a triangle that has an angle of 210 degrees. And the problem is triangles only go up to 180. So we need to extend the definition to handle these bigger angles. So as we look to this diagram here, I want to know if we're translating between the two systems, what is X going to be the same as if we went back to grade 10? So what is X the same as if we are kind of comparing these two definitions? And you can put it in the chat. What will X be the same as? So X in this situation, if you look at the triangle here, will be the adjacent, or we'll say it will be A. Okay, now, if we talk about Y, what will Y be the same as if we're comparing it to grade 10? So that would be the opposite, yeah. And then for R, what would R be the same as? I guess it's kind of obvious. R would be the hypotenuse. So sometimes we have to be able to move between those two worlds, and they are essentially the same. But the thing about having the X, Y, and R definition is if I want a triangle, say, in this quadrant over here, this definition can still work. So for example, if we had an angle in the third quadrant would be 180 to get to there. And then it would also need to be an extra bit. So let's say it would be theta. So that would be theta. And then the red one would just be 180 plus theta. This definition allows us to have a triangle. So if we were using this triangle here, this would be the R, this would be the Y, and this would be the X. And so using this idea, we could think about something like the sine of 210 making a triangle in the third quadrant. Now, I know that that's a little bit vague, but I just want you to have a rough idea. Now, I want to know, would X be positive or negative in this quadrant? So tell me in the chat. So you can see the way the quadrant is set up. X is going to be negative. What about Y? Is Y going to be positive or negative? So Y is going to be negative. And R, by definition, R is always positive. So this is only true of the third quadrant, though. Hey, if I was in a different quadrant, I may have a different combination of things going on. But because we're in the third quadrant, this makes sense. So let's just have a quick look here. If I wanted to know sine in this quadrant, so the sine in quadrant 3, sine is going to be what? Sine is going to be negative. So the sine of whatever the original angle was, let's say the sine of 210. The sine of 210 in this quadrant is going to be negative. Now let's think about in this quadrant in terms of Y's and R's. Sine is Y over R, and that means it's going to have negative over positive. So that's why we know that sine is negative in the third quadrant. Let me do it again for cos. What do you think is going to happen for the cos of 210? Well, the cos of 210 is x over r, and the third quadrant would just be negative over positive. So cos is negative in the second quadrant. Now, what about tan of 210? Do you think tan of 210 is going to be positive or negative? Tell me in the chat before I do it. Is tan of 210 going to be positive or negative? Okay, now we kind of know this from the last lesson, but just to show it to you from x, y, and r, tan is y over x, which according to what we did here, we have negative over negative, which means that negative over negative is a positive. And so this fortunately makes a lot of sense when we think about the cast diagram. In quadrant 3, only tan is positive. The other two ones are going to be negative. Now, I just wanted to give you a brief overview. This is probably the hardest part of the lesson, but I just want to give me a thumbs up if you broadly followed what I was talking about there. Give me a thumbs down if I lost you. I was just trying to show you how the X, Y, and R trig connects to the trig that you know about from grade 10. Okay, fantastic. All right. Now, not everyone has to get there yet. That's not a problem. It's a journey, but I just wanted to give it a crack at the beginning. So let's have a look at this drawing here. If in the last lesson, I was teaching you how to use the reduction formula on things that are bigger than like an acute angle. So the sine of 210 is an example I've got here. If you want to imagine what that looks like in terms of x, y, and r, the angle is going to be 180 plus theta. And what I said to you was, in the previous lesson, if you get something like the sine of 210, you have to rewrite it in a certain way. Can someone come and tell me what that new way was of writing? What was that different? What was that that way that we wrote it to make it easier to reduce a trig expression? Let's go to Masi. Masi, what do we have to do?
Hello, sir.
Hey.
So what we have to do is that we have to see if 210 is positive in the third quadrant first. Yeah. And then we're going to say sine, open bracket, 180 plus theta. And then we're going to continue to say sine, open bracket, 180 plus 30, because that's the answer. Yes. Then we're going to say sine negative 30. But because sine is negative in the third quadrant, it's going to become negative sine 30.
Perfect. Thank you so much, Masi. So if we think about this, there's a couple of different ways we can do it. But one of the things that we did was that we said, look, if you think about reducing 210, an important thing to say is in quadrant 3, all angles in quadrant 3 will have the form 180 plus theta. And so we can rewrite 210 as 180 plus 30. And then we ask ourselves, okay, I'm only interested in the angle which is inside the triangle. Now, if this is 210, the little bit inside it is just going to be 30. So I grab this 30 over here, and I ask myself, in this quadrant, is sine positive or negative? And it's negative, so the reduction formula is minus sine 30. Now, I want everyone to reduce the tan of 210 for me. So take the tan of 210, and I want you to rewrite that in terms of a reduced angle with a similar expression, and you can pop it in the chat. So if we imagine this as tan, so you should get plus tan 30. Now, this is absolutely perfect. And what I want to point out is that often when we start doing these things, you always end up doing this extra step to help you see how far away it is. But the real reason we use those reduction formulas is we want to see how far away it is from the nearest horizontal. So if you imagine, like, where is the nearest horizontal to 210? The nearest horizontal is here. So then if I know that 210 was my angle, then the nearest horizontal is 180. What's the difference between 180 and 30? 180 and 210, it's going to be 30. And so I'm going to teach you a quicker way today to do reduction, but just remember that it's always asking how far away is it from the nearest horizontal, because that shows you kind of what the angle is inside the triangle. Now, let me ask you to do another one, but this time I want you to do the sine of 330 and the cos of 330. I want you to reduce those two for me. Actually, the tan of 330 as well. We'll make it A, B, and C. A, B, and C. You can do this.
Yes, you've got this, guys.
So for those who are new, in the previous lesson, we said that all angles in this quadrant are 360 minus theta. All angles in this one are like this. These ones are like this. These ones are like this. So that might be helpful as a hint. Oh, what am I doing here? What is C going to be? Would anybody like to tell me how to do C? Anybody willing to share their thinking?
Anyone feeling a little brave today?
Yeah, let's go to, can we speak Inga? Yeah.
Hello, sir.
Hey, how's it going?
Good, how are you, sir?
Very good. How would you do C?
So, sir, I basically identified that 10 is negative because it's in the fourth quadrant.
Yes.
And so I decided to say 10, 360 minus 30. So I
Yeah.
got negative 1030.
Perfect. That's exactly it. Now, I want to ask you one question. If the question said, you can't use your calculator, but you need to give me a value for negative tan 30, do you have any idea how we could do that? You know how to use a calculator, but what other tools could we maybe use?
You use SOHCAHTOA, sir.
You could use SOHCAHTOA, but have you heard of a special triangle before?
Yes, sir. I heard of it.
Okay, so this is a special triangle that I taught, I think, in the second lesson. Tell me if you think it looks familiar. So it's got 60 and 30. Can you remember what's opposite the 30?
I can't quite remember it, sir.
Okay, I'm going to help you with it. So it's going to be 1 there. It's going to be √3 here, and it's going to be 2 there. And for those who weren't with us, you can go back and look at lesson 2. But now, you said use SOHCAHTOA. You're absolutely correct. So how could I get a value for tan of 30 using this triangle?
You basically identify which one is hypotenuse, adjacent, and opposite, sir.
Okay. And now where do I, what would the two values be? So
1 over square root 3, sir.
perfect. So because thank you so much. That was great, Ingo.
Pleasure, sir.
What we did here is we used the reduction formula, but we also did something a little bit extra. We used what's called a special triangle, and we evaluated that reduced angle using the special triangle. Now, give me a thumbs up if you understand how I did the special triangle. Give me a thumbs down if you don't. I just wanted to throw that in there for a bit of extra context. But I did cover it in lesson 2. So for those who didn't see it in lesson 2, I would definitely recommend going back. Okay, so it's a bit of a mixture. So definitely recommend going back to look at lesson 2, and you'll see all the details about that. But for now, I'm going to just have a look at something else. Now, we are going to start using the reduction formula, not just on numbers, but on expressions that have variables in. But one of the cool things that we can use is, like in the earlier one, we always asked ourselves, like, if it's in quadrant 3, I rewrote it in a way that made it obvious to me what the acute angle was. So for example, in this situation, the nearest horizontal was 180, and basically the difference between 210 and 180 is 30, and so 30 was the important bit. Now, if I give you an expression like this and I say reduce it, I'm going to use a very similar idea. I'm going to say, what quadrant is number 1 in? So I want, in the chat, tell me what quadrant 180 minus theta is in. It's in the second quadrant. Yes. So we know it's in the second quadrant. Now, is it positive or negative in that quadrant? So in the second quadrant, sign is positive. So this is going to be positive. Now, based on the pattern we've observed so far, this is going to be sine, and this is just going to be theta. Because we're taking, if we think about the drawing of 180 minus theta, we go 180 goes all the way there, and then it goes back a little bit. And so that is where I'm going to get to. And then that was the original, but the triangle itself is just going to have theta in it, even if this one over here is 180 minus theta. See if you can do number 2. I want you to try and do number 2 by yourself using the reduction formula. And someone can either come online and tell me how to do it or pop it in the chat. So this is going to be definitely a minus because cos is negative in this quadrant. And then it's going to be cos theta. Okay. That looks good to me. And from what I'm seeing in the chat, I'm liking it. Can I I want everybody to do question 3, 4, 5, and 6. If there are any questions, I want you to raise your hand, but let's just have a quick go at 3, 4, 5, 6 and see if you can reduce those for me. So when you put your answer in the chat, you can just say like 3 and then put your answer there, and 4 and so on. And I'm already getting some things coming through and recognizing that the third one is in the 4th quadrant. And I agree with that. It is in the 4th quadrant. Okay, over to you guys. Let's do this. So this is the 4th. Who would like to tell me how to do, I'll write the answer for 3 on the board. So that's going to be positive cos theta. Who would like to tell me how to do number 4? Oh, you're right. 4 and 6 are the same. So let's get rid of that. Who would like to share with me how to do number 4? You can just pop your hand up. Let's go to Trigonometry. Can we unmute there? Can you hear me? Maybe there's a...
Good afternoon, sir.
Hey, hey. What would you do
for number 4, cos 360 plus theta shows that the angle is greater than 360.
Yes.
So we have done a revolution to 360, then there's an additional angle from 360 to another quad. So it's on the 1st quadrant.
Perfect. Now, so that means it's positive. And then what's the second bit I write?
So you write positive cos theta.
Perfect. That is great. Thank you so much. I thought I'd catch you with that one, but no chance.
Yeah.
So what's important about this is a different type of reduction formula. And that's to say that it's 360 plus theta, which means you go all the way around and then you go into the 1st quadrant. For the second one, for tan 180 minus theta, that's in the 2nd quadrant. So tan will be negative, and it becomes negative tan theta for that one over there. Now, the thing that I want to point out to you about the reduction formula is it's basically 2 choices. If you are reducing off the horizontal, it's basically 2 questions. How far away is it from the nearest horizontal? The horizontals that we are currently using or can use are 0, 180. You could also have 360. Or if you were going the other way around, you could have minus 180 and minus 360. So you basically ask how far away are you from the nearest horizontal, and are you positive or negative in each quadrant? And that's pretty much reducing off the horizontal by itself. Let's do one more. If I say to you, what is the tan of 360 plus theta, the same as? And what is the sine of minus theta, the same as? Let's do these 2, and then we're going to have a break. Now, we haven't spoken about 8 yet, but I'm interested to see what you guys think. So 360 plus theta, that goes all the way around, and then an extra bit. So it must be a positive. And how far away is it from the nearest horizontal? It's going to be tan theta. Now, this is what we call a negative angle. And I haven't spoken too much about negative angles yet, but all that happens with a negative angle is it goes in this direction. So we ask ourselves, is sine positive or negative in this quadrant? In this quadrant 4, only cos is positive, so sine must be negative. And so the answer here would be minus sine theta. Give me a thumbs up if you understand number 8. Give me a thumbs down if you don't understand number 8. I just want to get a sense of, if I was reducing negative angles, how that's going. I'll do one more like this. Okay, it's very much a mixture in the chat, so thank you for your feedback. Let's try and do this one. What about, let's do 2 more. What is the cos of minus theta? And for number 10, what is the tan of minus theta? See if you can answer those 2 using the patterns that I've showed you so far. So if I want to visualize a negative angle, it goes this way. And in this quadrant, cos is positive. And how far away is it from the nearest horizontal? It's theta. So we get positive cos theta. Who would like to tell me how to do number 10? I'd love to hear a student voice. How do we reduce the tan of negative theta? Okay, Juliet, let's come to you. Tell us how we do number 10.
Oh, so no, I had a question for number 9.
No, that's fine. Go for it. Yeah.
So I just wanted to ask, why does cos have to be negative? Why does cos have to be positive since theta is negative?
Okay, great question. Great question. Do you remember the cast diagram?
Yes.
So it says that in quadrant 4, cos is always positive. Now, what's catching us is that a negative angle doesn't move counterclockwise, it moves clockwise. So if I give you negative theta, it means the angle moves into this quadrant. Now, because it's in this quadrant, cos is always positive in this quadrant. So that's why there's a positive sign over here. Does that make sense?
And the answer for number 10 is negative 10 theta.
Perfect. Can you see why that one has to be negative? Because in that quadrant, tan is negative.
Okay.
Perfect. Love it. Okay, everyone, we've done super well. It is time to have a little break. So I want you on your feet and I want you standing up with me. And we're going to do a 2-minute power up. So step 1 is to get those shoulders out and just do some small circles. I want everyone on their feet, small circles, and big circles. Okay. And then second exercise is to twist a little bit. First, only a bit, And as your body relaxes, I want you to stretch almost from 0 to 180. And then what I want for the last one is we're going to do some cardio. And we are going to do jumping jacks. So I want everybody standing up, cameras on, and we're going to do 10 jumping jacks, which means jumping with your hands and your feet. And let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 more. 1, 2, 3, 4, 5. And sit back down. And have a drink of water if you have some nearby. And hopefully your body is
Energized.
energized, yeah. Okay, here's your question for today. You go to the doctor because you are ill, and he prescribes you with 3 pills and tells you to take them every half hour. How long do the pills last you? Put your answer in the chat. So
I feel like this is a trick question.
it is a trick question. So when you take the pill straight away, then half an hour later, you take another pill. So 0, 30, and then you take another pill over here. So it should take you 60 minutes, which is 1 hour.
Oh, got a lot of you guys out there.
The benefit of drawing a diagram, but I always try to do something a little bit tricky with these. So I'll catch you again.
Don't worry, guys. Next time. Yeah, next one's one.
Yeah.
Yeah.
You always have to be aware that I'm going to do something a little bit special. Okay, let's go back to what we were doing. So if we look, there are many different types of reduction formula, but essentially the same ideas are gonna be used. So let's look at a question like this. I want everyone to, let's try and do number 2. So you're given this. I want you to try and do number 2 first of all. And then after you've done number 2, I want you to try and do number 4. But I'll do number 2 and then you can do number 4. So for number 2, what do I do first? I say to myself, what quadrant is tan in? It's in quadrant 4. And if I look at quadrant 4, how far away is it from the nearest horizontal? It's only going to be 60 degrees away. Now you can write this as 360 minus 60, but after a while you'll start to notice that there's a bit of a pattern here. So it's not 30, sorry, it's minus tan 60, because it's 60 degrees away from the nearest horizontal and tan is negative in that quadrant. Then for the cos of 120, that's going to be in this quadrant. How far away is it from the nearest horizontal? It's also going to be 60 away. And in that quadrant, cos is positive or negative. It's going to be negative. So I get negative cos 60. Now, in the end, I then get negative times a negative is a positive. So I get tan of 60 times the cos of 60. And if I wanted to evaluate that, I would use my special triangles. Okay. I will take any questions from students who want to ask questions, but let's try and do number 4 now. Let's try and do number 4. Itumeleng, let's go to you. Can we unmute Itumeleng?
Hi, sir.
Hey.
So, sir, like, I'm very confused now because of you said tan is in the fourth quadrant. If I'm
Yeah.
not wrong. Mara, according to that Cartesian plane, tan is in the third quad.
No,
So,
sorry,
like,
I meant yeah. So cos is in the fourth quadrant and tan is in the third. It's positive in the third quadrant.
yes.
Sorry, I must have made a mistake there.
Okay, no problem, sir.
Who has an idea for the cos of 780? What do we need to do for that? Maybe you can give us a tip in the chat, or you can tell us you can put your hand up. How do we handle 780? Let's go to Chevagavazzo.
Sir,
Yes.
I have a question for cos 780.
Yes.
If we cannot find the special angle when adding or
Yes.
subtracting, do we have to simplify the angle that we found? Because I found 360 plus 420. Do I have to simplify 420 so that I can get a special angle?
You do, but I tell you what, why don't we try and find out what quadrant 780 is in? Because if we could figure out what quadrant it's in, it might go quicker. So would you, if I start with 360, then if I go round again, what do I get to?
450.
Yeah, but if you keep going, so 360, if you add it in your calculator, what's 360 plus 360?
720.
20. Okay, so in one way of thinking of it is you can think of it as cos 360 plus 360. What's the last little bit going to be to get 780?
It's going to be 60.
60. So if we were visualizing that, it would basically be ending up in quadrant number 1. Would you be okay with that? Like if it was 60 degrees in quadrant 1?
Yes, sir.
Now tell me, using this idea, is it going to be positive or negative in quadrant 1?
It's going to be positive.
Yes. So this becomes plus cos 6. Yeah.
Okay.
Which is a special. So we could evaluate that if we use special triangles. But I'm going to thank you for that. That was super helpful. It was a really good question. Okay. Well done. I see some good questions going on in the chat. So what about sine of 315? What's that going to be? So there's two ways we can do it. There's the right side, that's 360 minus 45. Or we can say, look, if I go to 315, I think I get to here. And how far away is that from the nearest horizontal axis? It's 45 away. So this should be minus sine 45. Because, or if you wanted to see it like I was doing it before, where I just go 360 minus 45, and then you get minus sine 45. But I've got another tricky one. What is the tan of 420 going to be? Okay. So 420 is going to be going all the way around. So 360 plus another 60 And in that quadrant, it's going to be positive. So I get plus tan 60. Now, if I wanted to evaluate this using special triangles, I would have to evaluate the cos of 60 minus the sine of 45 times the tan of 60. And I'm going to give you the two special triangles that you can use to help you. So here is one of the triangles. Here is another. This is going to be 45, 45. This is going to be 60 and 30. I want you to use those triangles to get an answer for this expression without a calculator. See what you get. So you're going to have to replace some stuff there, replace some stuff there, replace some stuff there. And then you can give me the answer. What is cos 60 going to be? Yeah, so no, I think cos of 60 is going to be a half. What about the sine of 45? So I need to make sure I go to the right triangle. So that's going to be O, H, and A. So it feels like 1 over root 2. Nice and body. And Zanele. And what about the tan of 60? What's that going to be? So I need to make sure I'm in the right triangle. This is going to be O over A. So root 3 over 1. Yeah. So really, if I'm not using a calculator, this is all I can get. I wouldn't be able to get further than that. But I just wanted to show you how the reduction formula links to special triangles. So we did the reductions, and then we used the triangles to get values. Nice, Cynthia. Nice, Amukalani. Can we have a quick vote? Thumbs up, because that was a hard one. Thumbs up if you could follow what I was doing. Thumbs down if you felt very lost. I just want to get a quick feel for the class. Okay, and hang in there. If you're not there yet, don't worry. We're going to keep practicing. And I will, okay, this is a mixture. So we're going to keep practicing. So Mbali and Zanetta, we use special angles when the teacher says you must evaluate this without the use of a calculator. So for example, here's a question where you just have to get a value and you're not allowed to use your calculator. Okay, I hear you loud and clear. Don't worry, for those who are struggling. Let us try and do a question like this one over here. I know it's a bit vague, but let's finish with this one today. I want you to start by, it says simplify without a calculator. So this is a typical exam question. And you are given 4 little pieces to break down. I want everyone to start by doing the yellow one. See what you get for that. Then do the blue one. Then do the green one. And then let's see if we can figure out the answer to this. And for those who are struggling, I'm going to go through it with you as we go. I'll give you some special triangles that you can use. Off we go. Yeah, Levels just put a link to the previous lesson. I think for those who missed those lessons, it'll be super helpful for you. Okay, so my reduction looks like this. So it's minus sine x times cos 30. I'll just say, if there's nothing there in front, we assume that it's a plus. And then times, so this times this times this. This can cancel out. So we're left with minus, oh, actually, and then the minus is a minus times a minus is a plus. So we're left with the cos of 30 times the tan of 30. And for this, we have to grab it from this triangle over here. And the cos of 30, so that would be O, that would be H, that would be A. And cos is √3 and then over 2. The tan of 30 would be 1 over √3. So do you agree with me? Cos of 30 is going to be √3 over 2. Tan of 30 is going to be 1 over √3. Now, I've noticed something. I can cancel something out here. I've got √3 on the top and √3 on the bottom, which means the final answer for this will just be a half. When taking out the signs, do they not leave a -1? They do. There's a minus sign. So good questions in the chat. There's a minus sign here, but there's another minus sign here. And so together they knock each other out to be a positive. Oh. So in this session, we have got up already to exam level types of questions. I know that you're not perfect yet, and we'll carry on a little bit in the next lesson. But I think we've made some good progress today in getting to the harder reduction formulas. And Lebo, I'm going to ask you to put the link to today's quiz in the chat. That would be awesome. And then, yeah, I would say to those students who are feeling a bit unsure, go back and watch the previous lessons. And yeah, are there any final questions before we finish off tonight? Or any other comments that anybody wants to make? Yeah, so the key with this is you just keep practicing. And if you keep practicing, I promise that you will eventually become super, super easy. Okay, cool. So when we're going to do identities, so Annie, we're going to do identities in lessons 7 and 8. So because we're going to spend 2 lessons on reduction formula, I've moved the big trig identity to lessons 7 and 8. So next week, we're going to do a little bit more reduction formula, and then we're going to move on to trig equations, and then identities 7 and 8. All right. Thanks, everyone. I will see you next week. Keep practicing, keep watching those videos, and I'll see